What's up, everybody? I'm Logan, also known as Astronaut. Today is going to be part one of a series doing the Pihut Maker Advent Calendar 12 Days of Codemas. This will be my first time doing anything like this. A little bit about me. I am a Linux sysadmin and I am studying cybersecurity at WGU. So let's get right on into it. Alright, for the unboxing, day one. See, the breadboard, cord, and a Raspberry Pi Pico. Maker Advent Calendar day number one, getting started. Welcome to your first day of your 12 Projects of Codemas Advent Calendar. Excited? We are too. This 12-day Advent Calendar will teach you how to code with MicroPython using a Raspberry Pi Pico, using software along with a selection of fun, popular components along the way. We're going to use code to make hardware interact with the real world. Each day we'll show you how to use the fun things you find in each box, explaining what they are, what they do, how to construct the circuit, and then how to code them with MicroPython using simple methods. The best bit, once you've completed the 12 projects of Codemas, you'll have a Raspberry Pi Pico along with a great stash of components with the knowledge and confidence to make your own projects with them. Alright, day one, getting started. You'll have noticed that the first box is larger than most of the others. This is to give you everything you need to build the foundations for the fun projects you'll be making over the 12 days. Box number one, contents. In this box you will find the Raspberry Pi Pico H with the headers pre-soldered, a 1 micro USB cable, and a 400-point solderless breadboard, which is all of this here. Today's project, we're going to get you set up and familiar with the Raspberry Pi Pico, including installing the software required to program the board, as well as running a couple of very easy projects to get grips with MicroPython. Introducing the Raspberry Pi Pico. The Raspberry Pi Pico is a powerful, flexible microcontroller board from, you guessed it, Raspberry Pi, the same folks who brought us the Raspberry Pi 5 and the Raspberry Pi Zero. The Raspberry Pi Pico is a different kind of Raspberry Pi though. It's a microcontroller board, not a microcomputer. The brain of the Pico is the RP2040 microcontroller chip, the little black square in the middle. Where you might use a Raspberry Pi 4, which has an operating system to play games, write stories, browse the web, the Raspberry Pi Pico is designed for physical computing projects where it can control the components such as LEDs, buttons, sensors, motors, and even other microcontrollers. The board has lots of pins around it called GPIO pins, which allow you to connect all sorts of components to make projects. These are controlled by code that you write. A map of the Pico's pins is available here. Don't worry too much about the different pins and labels yet. We'll be covering this over the next 12 days. The Pico can use many different programming languages. However, the most popular is MicroPython, which is what we'll be doing over the next 12 days. The board has a micro USB port, which gives it power and allows it to communicate with our computer for programming. There's a lot more to this little board, but we'll keep to the basics for now. Alright, software setup. We're going to install software called Thani, which allows us to program the Pico with MicroPython. MicroPython is a smaller, more efficient version of the Python 3 programming language designed to be used with microcontroller boards such as the Raspberry Pi Pico. If you've programmed with Python previously, MicroPython will feel very familiar, but don't worry, we're going to guide you every step of the way over the next 12 days. Thani is a Python IDE. An IDE is an integrated development environment. They let us write code by giving us lots of helpful features to avoid errors, make our code more readable, and provide lots of other benefits. Alright, so this is for the setup, which I've already done, so I'm just going to skip over this part. Alright, installing MicroPython on the Raspberry Pi Pico. We now need to install the MicroPython firmware on the Raspberry Pi Pico. This gives the Pico the basic software it needs to run MicroPython code that we'll send to it later. Plug the Pico board into the breadboard, the end where the number one is, and then plug the micro USB cable into the Pico. Your Pico should be fully inserted so that you can't see any of the metal legs or pins. The black plastic on the underside of the Pico should sit flush with the top of the breadboard. So as you can see, that's done. Let me turn this light on. All right. Now locate the little button on top of your Pico. This is the boot cell button, which when held while connecting the cable allows us to install different firmware onto the Pico. Hold down the button while plugging in the USB cable into your computer's USB port at the same time. You may see it pop up as a new device. Alright, so holding the boot cell button, I'm gonna plug it in. And let's see. Alright, you'll see something like MicroPython and a COM port. Like the example below, this may vary. Alright, click on this and you'll see a few options. Install MicroPython. Let's close that. Setting up Thani. Alright. Thani can be used with a range of development boards, so we need to tell it that we are using the Raspberry Pi Pico. So in the top, click Run, and then Configure Interpreter. And we're already using MicroPython, USB board, okay. So that should be good. You should now see your Raspberry Pi Pico on the left. Let's see. System exception files. Okay, so here we go. All right, I don't really need to see that. Activity 1, your first program, print. Let's make a very simple program and run it in your Pico. We'll tell the Pico to print some words known as a string of text. These words or strings are then printed to the shell window. The print function is something you'll use a lot when programming. It's a useful tool to see what's happening with the program, what part of the program is running, and can help when debugging projects. In the top panel, which should be called Untitled at the moment, copy and paste or enter the following line. Alright, so let's paste that. And let's click go. This is my Pico talking. Alright, so that worked. A few things to note. Print text strings always sit within inverted commas within brackets. The letter case is very important with MicroPython and other code languages. Our print is always print and never print with a capital P. Now try changing the text in between the inverted commas. You can write anything you want. This calendar is going to be awesome. The famous hello world, this is the one we'll do. Alright, click run, and looks like it worked. Activity 2, light the onboard LED. We now know where to write code in Thani and how to run a program. We'll be doing a lot more of that over the coming days, so for now let's jump straight into a bit of Blinky. The Pico comes with a little LED on board, which is attached to one of the Pico's RP2040 pins, GPIO 25. This pin isn't on one of the physical pins available around the edge of the board. We can tell our program to run this pin on and off whenever we like, which is a nice, easy first hardware project and can be handy as an indicator for your own projects later on. This is the beginning of getting your code to control physical things. Inputs and outputs. Our GPIO pins, the green ones from the pin map, can be set as inputs or outputs. We use inputs when we want something to send signals or voltage into the Pico, like a button or a sensor, and we use outputs when we want the Pico to send signals or voltage out to something else, like LEDs or buzzers. We're going to use an output here which will send voltage to the onboard LED to light it up. Imports. Take a glance at the first line of the example code below. When we write code in Thani, a lot of the time we need to add imports at the start. Imports bring in code from other places called modules or classes, but let's not get bogged down with that for now. That we need to make our program work. Usually these are from built-in modules. To use the GPIO pins, we always need to import pin, the code. Take another look at the example below. So what is it doing? The first line imports pin from the machine module on the first line, which simply allows us to use the GPIO pins. The second line is setting up one of our pins to allow us to use it in our code. This sets up GPIO 25 with the name onboard LED. We use pin.out at the end to tell MicroPython to set this pin as an output. The third line then finally sets the pin value to 1, which is high or on. 1 is always used for high, on, and 0 is used for low or off. Alright, so let's copy this into here. Copy the code and then hit the run button. So when I hit run, we should see the LED light up if it's working. Alright, that worked. Now try changing the 1 to a 0 and run it again, and it should turn it off. Alright. You can also try adding a print line at the bottom or show a message at the same time. Alright, day 1 complete. Well done, fellow maker. Today you have become an owner of your very own microcontroller, learned about the Raspberry Pi Pico, set up your Raspberry Pi Pico with Thani, created your first program, learned about the print function, and controlled a physical component with the code. Now get some rest and a good night's sleep, for tomorrow we will continue with the fun with day number 2. Alright everybody, I hope you enjoyed that. Come back tomorrow or possibly later today for day number 2. Thanks.